Hello, and welcome to this presentation, Testing VOR with a CMA180. In this presentation, you'll learn how to configure VOR signal generation using a Rohde Schwarz CMA180 radio test set. This presentation assumes a basic familiarity with VOR and the structure of VOR signals. If you're not already familiar with VOR, you might want to watch the presentation Understanding VOR before proceeding with this presentation. VOR is one of the supported avionics signal types on the CMA180. In other words, the CMA can generate VOR signals with user-defined parameters for the three components of a VOR signal, namely the reference signal, the variable signal, and the COM or COM ID signal. Recall that VOR consists of a carrier that's modulated by two 30 Hz signals, the reference signal, which has the same phase regardless of which radio we're on, and the variable signal, whose phase is different on each radial. The current radial is the same as the phase difference between reference and variable signal. For example, if the phase difference between reference and variable is 45 degrees, this means we're on the 4-5 radial. The COM ID signal component isn't used for determining the current radial, but rather contains a Morse code or voice signal that can be used to unambiguously identify the VOR station. To enter Avionics Mode on the CMA180, select Avionics from the list of available analog modes. There are four tabs under Avionics: VOR, ILS, Marker Beacon, and Analyzer. All VOR signal generation parameters are configured under the VOR tab. These parameters can be divided into two general areas. The first are the generic RF, connector, and control parameters. The second are the VOR-specific parameters for reference, variable, and COM ID signals. Let's start by looking at the general parameters for VOR signal generation. Frequency and level should be set appropriately, and any gain or loss in the RF output path can be indicated using the external attenuation parameter. Either RF COM or RF out can be used to output the VOR signal. Normally, VOR signal generation only begins when the generator or play button is pressed, but if Start Generator Automatically is enabled, the CMA will begin transmitting the VOR signal as soon as the Generator tab is selected. Under VOR-specific settings are three boxes, each corresponding to a component of the VOR signal: the reference signal, the variable signal, and the COM ID signal. In most cases, these parameters should be left at their default values when simulating a realistic VOR signal. The only VOR parameters that are commonly changed during simulation or testing are the bearing angle and the ID signal. Let's look at both of these in a little more detail. Recall that bearing angle is the phase difference between the reference and variable signals, and that this difference defines the VOR radial. If we're on the 8-5 radial, then the difference in phase between reference and variable is 85 degrees. Note, however, that we can designate a radial either as to or from. For example, this aircraft is on the 8-5 from radial because the angle from the VOR to the aircraft is 85 degrees. We could also express this as the angle from the aircraft to the station, which would be 85 plus 180 or 265 degrees. The signal produced by the CMA is exactly the same in both cases. The COM ID signal is used by pilots to ensure that they're tuned to the proper VOR station. Actual VOR stations transmit this ID signal either as Morse code or as a recorded voice message, but for testing purposes, a simple AM modulated tone is often used as the ID signal. The frequency of this tone and the modulation depth can also be configured. In summary, the CMA180 can be used to generate standard or customized VOR signals. The three basic parameters in VOR signal generation are the frequency, level, and the bearing angle or radial. In addition, the various components of the VOR signal can be enabled or disabled or modified. These are the reference signal, the variable signal, and the COM ID signal. This concludes our presentation, Testing VOR with the CMA180. Thanks for watching.